So far, as we've studied organic chemistry, we've learned a lot about compounds that contain only carbon and hydrogen. But when it comes to organic compounds, this is just a small percentage of the amount of compounds that do exist. And that's because sometimes those hydrogens get replaced by different elements like oxygen or nitrogen or all sorts of different things. And what we're going to learn about today is one specific group that can replace those hydrogens that are called the halogens. So these are elements out of the 17th family, or the halogen family, on the periodic table. When we're working with these, they have very similar properties to an alkane, but tend to be a little bit more reactive. And in order to differentiate them, we have our own naming system. This naming system is based all on prefixes. Now, when it comes to using this prefix system, what we do is identify the type of halogen using a prefix in front of the name. So for a fluorine, we use the prefix fluoro. Chlorine, we use the prefix chloro. Bromine, bromo. Iodine, iodo. Other than that, naming is actually pretty much the same as everything else we've done so far. We are going to number based on the lowest sum of numbers possible. We are going to name the longest chain of carbons using a prefix and suffix system to show the number of carbons and the bonding structure. And at this level, we're only really going to deal with alkanes to make sure that we only have single bonds. So let's take a look at some examples. So here we have several different examples of haloalkanes. So in example number 1, you can see we're dealing with CH3, CH2, and then attached to the very end we have a bromine. So if we wanted to name this, what we want to do is find our parent chain. And in order to do that, we need to look at the carbons in this compound. And there are 2 carbons. That means we are going to use the prefix eth. And to show that there is a single bond that exists between those 2 carbons, we're going to use the suffix ane. So we get ethane. But we know it's not just ethane, it has this bromine attached to it. So we add the prefix bromo to show that there is a bromine at the beginning of this compound. And we have to show the position of this bromine. So we name it 1-bromoethane. If we were to look at this compound here, this compound may look like a methyl group with a iodine attached to a 2-carbon chain, but in actuality we have a 3-carbon chain here. This 3-carbon chain makes this a type of propane. So we're going carbon number 1, number 2, and then number 3. Single bonds exist between all of them, but we have this iodine attached, so we need to add the prefix iodo, and it is in the 2 position, so we have 2-iodo-propane. In this example, we want to still find our longest chain of carbons. So any way you count this, you're going to see that you have a 1, 2, 3, 4 carbon chain. Now, if you wanted to, you could make this carbon number 1 up here, and this would be the methyl group over here, but it doesn't actually matter. You're going to get the same thing no matter what. So when it comes to naming this, we actually have 2 things attached. We have a methyl group and a chlorine group on a 4-carbon chain. So the 4-carbon chain gives us butane. And then we have to think about our prefixes. Now, we name our prefixes alphabetically even when it comes to these halogens. So on the 2 position, I have a chloro, and on the 2 position, I have a methyl. I'm just going to tighten this up so it all fits. So we have 2-chloro, 2-methyl butane. And that would be how we name these compounds. Okay, so now that we've seen those examples, let's do one with a little bit more to it. So here we have our carbon chain. It has two different halocarbon or halogens attached. So how would we go about naming this? Well, same method as always. Find your longest continuous chain. In this case, it's 1, 2, 3, 4, 5 carbons, which gives you pentane. Now remember the ANE ending is because these are all shown as single bonds. So there's no double bonds, triple bonds in this molecule. We then need to number and name these things, and we want to do it so that we get the lowest sum of numbers possible. So what that means is this is going to be carbon 1, carbon 2, carbon 3, 4, and 5. And so then what we want to do is we want to name them alphabetically. So bromo is going to come before chloro. So we have 3 bromo, 2 chloropentane. So naming halocarbons isn't really too big of a departure from when we used alkyls and just straight alkanes. Just as long as we remember our prefixes and remember we're going for the lowest sum of numbers possible and making sure we put things in alphabetical order. So thanks for watching, and I'll see you next time.